kind of more familiar to AI people, it's basically usually described as solving search problems. But the idea here is that if you have a problem of the form, find a number that satisfies some property, then if with a classical computer you need to try kind of n times before you find a number, then with a quantum computer you only need to do square root of n computations. And Grovers could potentially be used for mining, but there's two possibilities here. One is that Grovers could be used for mining, and whoever creates the first working quantum computer that could do Grovers will just mine way faster than everyone else, and we'll see another round of what we saw when ASICs came out, which is that kind of the new hardware just kind of dominated the old stuff, and then eventually it switched to a new equilibrium.
But by the way, way faster, not exponentially faster.
Quadratically faster.
Quadratically faster, which is not sort of... it's not game-changing, I would say. It's more like ASICs, like you said, it would be...
Exactly. Yeah, so it would not necessarily break proof of work as a thing.
That's right, yeah.
Now, the other kind of possible world, right, is that quantum computers have a lot of overhead, there's a lot of complexity involved in maintaining quantum states, and there's also, as we've been realizing recently, making quantum computers actually work requires kind of quantum error correction, which requires kind of 1,000 real qubits per logical qubit, and so there's the very real possibility that the overhead of running a quantum computer will be higher than the speed up you get with Grovers. Which would be kind of sad, but which would also mean that given proof of work would just keep working fine.
So, beautifully put. So proof of work is the core idea of Bitcoin. Is there other core ideas before we kind of take a step towards the origin story and ideas of Ethereum? Is there other stuff that were key to the white paper of Bitcoin?
There's proof of work, and then there's just the cryptography, just kind of public keys and signatures that are used to verify transactions. Those two are the big things.
So then what is the origin story? Maybe the human side, but also the technical side of Ethereum.
Sure. So I joined the Bitcoin community in 2011, and I started by just writing. I first wrote for this sort of online thing called Bitcoin Weekly. Then I started writing for Bitcoin Magazine.
Sorry to interrupt. You have this funny kind of story, true or not, is that you were disillusioned by the downsides of centralized control from your experience with World of Warcraft. Is this true, or you're just being witty?
I mean, the event is true. The fact that that's the reason I do decentralization is witty.
Maybe just a small tangent. Have you always had a skepticism of centralized control? Is that...
To some degree, yeah.
Has that feeling evolved over time, or has that just always been a core feeling that decentralized control is the future of a human society?
It's definitely been something that felt very attractive to me ever since I could have learned that such a thing is possible.
It's possible, even technically.
Yeah.
So great. So you joined the Bitcoin community in 2011, you said. You began writing. Mm-hmm. So what's next?
Started writing... moved from high school to university, halfway in between that, and spent a year in university. Then at the end of that year, I dropped out to do Bitcoin things full-time. And this was a combination of continuing to write Bitcoin Magazine, but also increasingly work on software projects. And I traveled around the world for about 6 months and just going to different Bitcoin communities. Like, I went to first in New Hampshire, then Spain, other European places, Israel, and then San Francisco. And along the way, I've met a lot of other people that are working on different Bitcoin projects. And when I was in Israel, there were some kind of very smart teams there that were working on ideas that people were starting to kind of call Bitcoin 2.0. So one of these was colored coins, which is basically saying that, hey, let's not just use the blockchain for Bitcoin, but let's also kind of issue other kinds of assets on it. And then there was a protocol called Mastercoin that supported issuing assets, but also supported many other things, like financial contracts, like domain name registration, and a lot of different things together. And I spent some time working with these teams, and I quickly kind of realized that this Mastercoin protocol could be improved by kind of generalizing it more, right? So the analogy I use is that the Mastercoin protocol was like the Swiss Army knife. You have 25 different transaction types for 25 different applications, but what I realized is that you could replace a bunch of them with things that are more general purpose. So one of them was that you could replace like 3 transaction types for 3 types of financial contracts with a generic transaction type for a financial contract that just lets you specify a mathematical formula for kind of how much money each side gets.
By the way, just a small pause. You say financial contract, just the terminology. What is a contract? What's a financial contract?
So this is just generally an agreement where kind of either one or two parties kind of put collateral kind of in, and then they, depending on kind of certain conditions, like this could involve prices of assets, this could involve the actions of the two parties, it could involve other things. But they kind of get kind of different amounts of assets out that just depend on things that happened.
So a contract is really a financial contract is at the core. It's the core interactive element of a financial system.
Yeah, there's many different kinds of financial contracts. Like there's things like options where you kind of give someone the right to buy a thing that you have for some specific price for some period of time. There's contracts for difference where you basically are kind of making a bet that says like, for every dollar this thing goes up, I'll give you $7, or for every dollar the thing goes down, you give me $7 or something like that.
But the main idea that these contracts have to be enforced and trusted.
Yes, exactly.
You have to trust that they will work out in a system where nobody can be trusted.
Yes.
This is such a beautiful, complicated system. Okay, so you were seeking to kind of generalize this basic framework of contracts.
Mm-hmm.
So what does that entail? So what technically are the steps to creating Ethereum?
Sure. So I guess just to kind of continue a bit with this Mastercoin story.
Sure.
So started by kind of giving ideas for how to generalize the thing, and eventually this turned into a much more kind of fully fledged proposal that just says, hey, how about you scrap all your features and instead you just put in this programming language. And I gave this idea to them, and their response was something like, hey, this is great, but this seems complicated, and this seems like something that we're not going to be able to put onto our roadmap for a while. And my response to this was like, wait, do you not realize how revolutionary this is? Well, I'll just go do it myself. And then
What was the name of the programming language?
I just called it Ultimate Scripting.
Great.
So then I kind of went through a couple more rounds of iteration, and then the idea for Ethereum itself started to form. And the idea here is that you just have a blockchain where the core unit of the thing is what we call contracts. It's these kind of accounts that can hold assets and that have their own internal memory, but that are controlled by a piece of code. And so if I send some ether to a contract, the only thing that can determine where that kind of ether, the currency inside Ethereum, kind of goes after that is the code of that contract itself. And so basically kind of sending assets to computer programs becomes this kind of paradigm for creating these kind of self-executing agreements.
Self-executing. It's so cool that code is sort of part of this contract.
Mm-hmm.
So that's what's meant by smart contracts.
Yeah.
So how hard was it to build this kind of thing?
Harder than expected. Originally I actually thought that this would be a thing that I would kind of casually work on for a couple of months, publish, and then go back to university.
Mm-hmm.
Then I released it, and a bunch of people, or I released a white paper.
The white paper, the idea is there.
Yeah. The white paper. A whole bunch of people came in offering to help. A huge number of people have expressed interest, and this was something I was totally not expecting. And then I kind of realized that this would be something that's kind of much bigger than I had ever thought that it would be. And then we started on this kind of much longer development slog of making something that kind of lives up to this sort of much higher level of expectations.
What are some of the Is it fundamentally like software engineering challenges?
It
Is
was.
there social? Okay, so there's
And social.
so what are the biggest interesting challenges that you've learned about human civilization and in software engineering through this process?
So I guess one of the challenges for me is that like I'm one of the kind of apparently unusual geeks who was kind of never treated with anything but kindness in school.
Yes.
And so when I got into crypto, I kind of expected everyone would just kind of be the same, kind of altruistic and nice in that same way. But the kind of the algorithm that I used for finding co-founders for this thing was not very good. It was kind of literally what computer scientists call the greedy algorithm. It's kind of the first 15 people who replied back offering to help kind of are the co-founders.
Oh, you mean like literally the people that will form to be the founders, co-founders of the community. The algorithm. I like how you call it the algorithm.
Yeah, and so what happened was that these like especially as the project got really big, like there started to be a lot of this kind of infighting, and there were a lot of like I wanted the thing to be a nonprofit, and some of them wanted to be a for-profit, and then there started to be people who were just kind of totally unable to work with each other. There were people that were kind of trying to get an advantage for themselves in a lot of different ways, and this just about 6 months later led to this big governance crisis, and then we kind of reshuffled leadership a bit, and then the project kept on going. Then 9 months later there was another governance crisis, and then there was a third governance crisis, and so
is there a way to, if you're looking at the human side of things, is there a way to optimize this aspect of the cryptocurrency world? It seems that there is from my perspective, there's a lot of different characters and personalities and egos, and like you said, I don't know if, I also like to think that most of the people in the world are well intentioned, but the way those intentions are realized may perhaps come off as as negative. Like what is there a hopeful message here about creating a governance structure for cryptocurrency that where everyone gets along?
And after about 4 rounds of reshuffling, I think we've actually come up with something that seems to be pretty stable and happy. I think, I mean, I definitely do think that most people are well-intentioned. I just think that like one of the reasons why I like decentralization is just because there's like this thing about power where power attracts people with egos, and so that just allows us a very small percentage of people to just ruin so many things.
You think ego has a use? Like, is ego always bad?
It sometimes does. Within the Ethereum research team, I feel like we've found also kind of a lot of very good people that are just primarily just interested in things for the technology, and things seem to just generally be going quite well.
Yeah, when the focus and the passion is in the tech. So that's the human side of things. But on the technology side, like what have you learned? What have been the biggest challenges of bringing Ethereum to life on the technology side?
So I think first of all, just there's like the first law of software development, which is that when someone gives you a timetable, switch the unit of time to the next largest unit of time and add one. Yes. And like we basically fell victim to that. And so instead of taking like 3 months, it ended up taking like 20 months to launch the thing. And that was just, I think, underestimating the sheer technical complexity of the thing. There were research challenges, like so. For example, one of the things that we've been saying from the start that we would do, one is a switch from proof of work to proof of stake, where proof of stake is this alternative consensus mechanism where instead of having to waste a lot of computing power on solving these mathematical puzzles that don't mean anything, you kind of prove that you have access to coins inside of the system, and this kind of gives you some level of participation in the consensus.
Can you maybe elaborate on that a little bit? I understand the idea of proof of work. I know that a lot of people say that the idea of proof of stake is really appealing. Can you maybe linger on it longer, explain what it is?
Sure. So basically, the idea is like, if I kind of lock up 100 coins, then I turn that into a kind of quote virtual miner, and the system itself kind of automatically and randomly assigns that in a virtual miner the right to create blocks at particular intervals. And then if someone else has 200 coins and they unlock those 200 coins, then they get a kind of twice as big virtual miner. They'll be able to create blocks twice as often. Right? So it tries to kind of do similar things to proof of work, except instead of the thing kind of rate limiting your participation being your ability to crank out solutions to kind of hash challenges, the thing that rate limits your participation is kind of how much coins you're kind of locking into this mechanism.
Okay, so interesting. So that limit of participation doesn't require you to run a lot of compute.
Mm-hmm.
Does that mean that the richer you are,
Mm-hmm.
so rich people are more, like their identity is more
Right, and this,
stable,
yeah,
verifiable, or whatever the right terminology is.
right, and this is definitely a common critique. I think my usual answer to this is that, like, proof of work is even more of that kind of system.
Yes, exactly.
Yeah,
I didn't mean it in that statement as a criticism. I think you're exactly right. That's equivalent. The proof of work is the same kind of thing, but in the proof of work, you have to also use physical resources.
Yes, and burn computers and burn trees and all of that stuff.
Is there a way to mess with the system of the proof of stake?
There is, but you will once again need to have a very large portion of all the coins that are locked in the system to do anything bad.
Got it. So yeah, and just to that, maybe take a small tangent. One of the criticisms of cryptocurrency is the fact that I guess for the proof of work mechanism, you have to use so much energy in the world.
Yes.
Is one of the motivations of proof of stake is to move away from this?
Definitely.
Like, what's your sense of it? Maybe I'm just underinformed. Is there like legitimately environmental impact from this?
Yeah. So the latest thing was that Bitcoin consumed as much energy as the country of Austria or something like that.
Okay.
Yeah, and then Ethereum is like right now maybe only like half an order of magnitude smaller than Bitcoin.
I've heard you talk about Ethereum 2.0. So what's the dream of Ethereum 2.0? What's the status of proof of stake as the mechanism that Ethereum moves towards? And also, how do you move to a different mechanism of consensus within a cryptocurrency?
So Ethereum 2.0 is a collection of major upgrades that we've wanted to do to Ethereum for quite some time. The two big ones, one is proof of stake, and the other is what we call sharding. Sharding solves another problem with blockchains, which is scalability. And what sharding does is it basically says, instead of every participant in the network having to personally download and verify every transaction, every participant in the network only downloads and verifies a small portion of transactions. And then you kind of randomly distribute who gets how much work. And because of how the distribution is random, it still has the property that you need a large portion of the entire network to corrupt what's going on inside of any shard, but the system is still kind of very redundant and very secure.
That's brilliant. How hard is that to implement, and how hard is proof of stake to implement? Like on a technical level, software level.
Proof of stake and sharding are both challenging. I'd say sharding is a bit more challenging. The reason is that proof of stake is kind of just a change to how the consensus layer works. Sharding does both that, but it's also a change to the networking layer. The reason is that sharding is kind of pointless if at the networking layer you still do what you do today, which is you kind of gossip everything, which means that if someone publishes something, every other node in the client hears it from on the networking layer. And so instead we have to have kind of sub-networks and the ability to quickly switch between sub-networks and have the sub-networks talk to each other. And this is all doable, but it's a more complex architecture, and it's definitely the sort of thing that has not yet been done in cryptocurrency.
So most of the networking layer in cryptocurrency is you're shouting, you're like broadcasting messages, and this is more like ad hoc networks. Like
you're shouting within smaller groups.
Smaller group, but you have like a bunch of
Exactly.
And you have to switch between. Oh man, I'd love to see that. So it's a beautiful idea. So from a graph theoretic perspective, but just the software that who's responsible? Is the Ethereum project, like the people involved, would they be implementing? Like, what's the actual? This is like legit software engineering. How does that work? How do people collaborate, build that kind of project? Is this like almost is there a software engineering lead? Is there? Is it a legit, almost like large scale open source project?
There is, yeah. So we have someone named Danny Ryan on our team who's just been brilliant and great all around, and he is a kind of de facto kind of development coordinator, I guess. It's like you have to invent job titles for this stuff, and the reason is that we also have this unique kind of organizational structure where the Ethereum Foundation itself kind of does research in-house, but then the actual implementation is done by independent teams that are separate companies, and they're located all around the world in fun places like Australia. And so you kind of just need a bunch of almost nonstop cat herding to just keep getting these people to kind of talk to each other and kind of implement the spec, make sure that everyone agrees on kind of what's going on and kind of how to interpret different things.
So how far into the future are we from these two mechanisms in Ethereum 2.0? Like, what's your sense of the timeline, keeping in mind the previous comment you made about the sort of general curse of software projects?
So Ethereum 2.0 is split into 3 phases. So phase 0 just creates a proof-of-stake network, and it's actually separate from kind of the proof of work network at the beginning, just to kind of give it time to grow and improve itself.
Do people get to choose? Sorry to interrupt. Do people get to choose? I guess.
Yes, they get to choose to move over if they want to. Then phase 1 adds sharding, but it only adds sharding of kind of data storage and not sharding of computation. And then after that, there is kind of the merger phase, which is where the kind of the accounts, kind of smart contracts, like all of the activity on the existing ETH1 system just kind of gets cut and pasted into ETH2, and then the proof of work chain gets forgotten, and then all of the things that were living there before just kind of continue living inside of the proof of stake system. So for timelines, phase 0 has been kind of almost fully implemented. And now it's just a matter of a whole bunch of security auditing and testing. My own experience is that right now it feels like we're at about a phase comparable to when we were doing the original Ethereum launch, when we were maybe about 4 months away from launch.
So that's just a hunch. Then
that's just a hunch, yeah.
So how it took like over a decade for people to move from Python 2 to Python 3. How do you see the move from this phase 0 for different consensus mechanism? Do you see there being a drastic phase shift in people just kind of jumping to this better mechanism?
So in phase 0, don't expect too many people to do much, because in phase 0 and phase 1, the new chain deliberately doesn't have too much functionality turned on.
Right.
It's there just like if you want to be a proof of stake validator, you can get things started. If you want to store data for other blockchain applications, you can get started. But existing applications will largely keep living on ETH1. And then when the merger happens, then the merger is a operation that happens all at once. So that's kind of one of the benefits of a consensus system, that on the one hand you have to coordinate the upgrade, but on the other hand the upgrade can be coordinated.
So what's Casper FFG, by the way?
Casper FFG is the consensus algorithm that we are using for proof of stake.
Is there something interesting specific about Casper FFG, like some beautiful aspect of it that's
there is. So Casper FFG combines together kind of 2 different schools of consensus algorithm design. So the general 2 different schools of this design are, right, one is kind of 50% fault tolerant but dependent on network synchrony. So 50% fault tolerant, but it can tolerate up to 50% of faults, but not more. But it depends on an assumption that all of the nodes can talk to each other within a limited period of time. Like if I send a message, you'll receive it within a few seconds. And the second school is 33% fault tolerant, but safe under asynchrony, which means that like if we agree on something, then that thing is finalized, and even if the network goes horribly wonky the second after that thing is finalized, there's no way to revert that thing. And
that's fascinating how you would make that happen.
It's definitely quite clever. I'd recommend the Casper FFG paper. If you just search like archive, as in like ARXIV Casper FFG,
that's
right
an archive. There. The paper's an archive.
Yeah.
Who are the authors?
Myself and Virgil Griffith.
That's awesome. I take a small tangent. This idea of just putting out white papers and putting them on archive and just putting them publicly, is that at the core? Is that a necessary component of cryptocurrency? Is that the tradition started with Satoshi Nakamoto? What do you make of it? Like, what do you make of the future of that kind of sharing of ideas?
I guess so, yeah. And it's definitely something that's like kind of mandatory for crypto, because like crypto is all about making systems where you don't have to trust the operators to trust that the thing works. And so if anything behind how a system works is closed sourced, then that kind of kills the point. And so there is the kind of a sense in which the fundamental properties of the category of the thing we're trying to build just kind of forces openness. But also openness just has proven to be a really great way to collaborate. And there's actually been a lot of kind of innovation and academic collaboration that's just kind of happened ad hoc in the crypto space the last few years. So like, for example, we have this forum called ETH Research. That's like ETHRESEAR and then .ch. And there we publish kind of just ideas in a form that's kind of half formal. Like it's halfway in between, like it's a kind of a text write-up, and then you can have math in it, but it's often kind of much shorter than a paper. And it turns out that the great majority of new ideas, like they're just kind of fairly small nuggets that you can explain in like 5 to 10 lines, and they don't really...
They don't need the whole formality of a paper, right?
Exactly. They don't require the kind of like 10 pages of a filler, and so...
Introduction, conclusion is not needed.
Yeah, and so instead you just kind of publish the idea, and then people can go comment on it. And
that's brilliant.
Yeah, no, this has been really great for us.
I think I interrupted you. Was there something else on Casper FFG?
So just Casper FFG is just kind of combines together these two schools, and so basically it creates this system where if you have more than 50% that are honest, then and you have network synchrony, then the thing kind of goes as a chain. But then if network synchrony fails, then kind of the last few blocks in the chain might kind of get replaced, but anything that was finalized by this kind of more asynchronous process can't be reverted. And so you essentially get a kind of best of both worlds between those two models.
Okay, so I know what I'm doing tonight. I'm going to be reading the Casper FFG paper. Apologize for the romanticized question, but what to you are some or the most beautiful idea in the world of Ethereum? Just something surprising, something beautiful, something powerful.
Yeah, I mean, I think the fact that money can just emerge out of a database if enough people believe in it, I think, is definitely one of those things that's up there. I think one of the things that I really love about Ethereum is also this concept of composability. So this is the idea that like, if I build an application on top of Ethereum, then you can build an application that talks to my application, and you don't even need my permission, you don't even need to talk to me, right? So one really fun example of this is there was this kind of game on Ethereum called Crypto Kitties that just involved kind of breeding digital cats.
Yes.
And someone else created a game called Crypto Dragons, where the way you play Crypto Dragons is you have a dragon and you have to feed it Crypto Kitties.